Hello, everybody. Welcome to the Kelley Parker YouTube channel, where you will learn about everything from technology to video games to consumer electronics and beyond. And if you enjoyed what you learned today, be sure to like this video, comment, subscribe, hit that bell for notifications so you are updated the moment I upload new content. And for the first video here on this channel, I will be talking about IPv4 addresses, or what you commonly know as IP addresses. And obviously, all your smartphones have IP addresses when they connect to the mobile network towers. Your computers at home have IP addresses. And of course, your EC2 instances might have public IP addresses on those as well. But it's important to know the originations and the founding philosophy of distributing IPv4 addresses to the world at large. And IP addresses started back in the early 1980s and were distributed to organizations via the framework outlined on RFC 870. So again, we're only going to be focusing mainly on the classes of IPs, the common classes of IPv4 addresses that are used in the world today that you've probably seen. So starting with Class A IPs, they were distributed in /8 blocks. That's a CIDR block, or classless interdomain routing notation of describing a range of IPs in short form. Long story short, a Class A IP block would net you about 16.7 million IPs. And that's reserved for like large institutions in research, commercial, or military, and so forth. AT&T had a block, 12.0.0.0 to 12.255.255.255. Likewise for Apple, replaced the 12 with the 17. They acquired huge blocks of IP addresses. But you may ask, did they actually use all those IP addresses? No, that resulted in wasteful block distributions of IPs because you only have such a finite available number of IPs available out there. So there have been additional solutions made to alleviate the exhaustion of IPv4 addresses, such as CIDR, classless interdomain routing, variable length submasks, and IPv6. And to continue down the list of classes of IPs, you have your Class B IP addresses, which range from 128 up to 192, reserved for medium companies and organizations. The CIDR block notation would be 16 or /16 blocks, and each block would be 65,534 IPs. So whenever Rutgers or Maryland acquired their IP blocks, they acquired exactly 65,534 usable IPs. And we go down to Class C. We have 192 all the way up to 224. Again, for small companies, organizations, /24 CIDR block notation, you get about 254 usable IPs per block. And you'd have institutions like Hewlett-Packard and New York University Network use these blocks of IPs. And just because I show New York University Network and Hewlett-Packard as using those specific public IPs, that doesn't mean you're restricted to just one block of IP. You could acquire as many blocks as you needed at the time, just depending on your needs. It's just that these classful maxes that you see here, Class A of 16.7 million, Class B of 65,000, and Class C of 254, those were fixed amounts. So it's like going to Costco or going to Sam's Club and only having an option of buying, I'm going to throw theoretical numbers out here, a bulk of 3 bottles versus a bulk of 100 bottles versus a bulk of 50,000 bottles of water, right? Like, those sizes might not be appropriate. You actually might need 64, but you don't want to buy 3 because you'd have to buy like 32 or so of those, or 20 of those. And then you don't want to buy 100 because you might have 30 some odd wasted bottles, right? Same concept was faced, or the same situation was faced back in the early 1980s with the distribution of IP addresses. And that brings us to our last 2 classes of IP addresses, which aren't publicly available. They're actually used for other functions. And we'll talk about the Class D range of IPs that range from 224 all the way up to 240. And these are multicast addresses, not publicly routable. So if you do the math, that's about 268 million IP addresses. First question you might ask is, Kelley, how come that many IP addresses aren't available to use? Well, honestly, this was in the very early days of internet. It was unforeseen how much the internet has exploded just a few years after RFC 870 was written. So although hindsight is 2020, there are additional measures now to kind of slow the exhaustion of IPv4 addresses. Of course, you have IPv6 that already has been in existence for at least several decades now. So it's kind of a moot point to kind of address all of the wasted IPs here. But that's just kind of a side note just to keep in the back of your mind. So multicast is transparent. It's really handled by your network drivers on your computer. So whenever you're running applications like video conferencing systems, financial market data distribution, or IPTV, this is all handled from within your computer, within your operating system. Multicast addresses aren't really something you really have to think about configuring. They're kind of configured in the background, so you don't really have to think about those. And then the most mysterious class of them all, I think, is a Class E IPs, ranging from 240 all the way to the end, at the end of the 255 range. Experimental, listed for future use, reserved. Again, this was developed in 1983. Keep that in mind. Several years before I was even born. So I'm guessing the concept was that let's reserve all these additional millions of IPs for some other use. But after asking ChatGPT and doing some research on the internet, I never could find an actual use for IPs in this range that have been public to my knowledge. So again, these are additional IPs that will never see the light of day in terms of public use because they were just never fully utilized. So now I want to take the time to touch up on the special IP ranges that you may be familiar with. I guarantee at least one point in your life, you've actually seen some of these IPs in use. So, and you're probably using them right now if you're watching from home. So let's talk about those real quick. So you've got private IP ranges. These are mentioned in RFC 1918. And each of the three public classes of IPs, they have what's called a private IP range. And you may be asking, what does a private IP range do? Well, they're IPs that cannot be publicly routed over the internet. So they're used for internal use. So if you have an IP address of 192.1.1 at home, there's probably at least an infinite more number of people out there that have that same IP as they connect to the router at home. And these are reserved ranges, as I said, indicated in RFC 1918. So for Class A, you have 10.0.0.0 all the way to 10.255.255.255 written down in a 10.0.0.0/8 CIDR notation. And that gives you, like I said earlier with the Class A blocks, that gives you about 16.7 million possible IPs that you could use on your home network. I highly doubt anyone is using even close to that, and much less even 100 of those IPs. But you could technically set up your router to do that, to distribute Class A IPs if you wanted to. But just so you know, that is a reserved private range. Again, this was established many years ago. RFC 1918 was written in February 1996. But to continue on, for your Class B special IP range, you got 172.16.0.0 to 172.31.255.255, and you get about 65,000 available private IPs to use there. And then you have your Class C, which is probably the most common range that's already pre-configured on your routers at home, because you get 254 usable IPs in the range of 192.168.0.0 to 192.168.0.255. And this may be a familiar range of numbers for you because your router instruction manual likely tells you be sure to connect to your router at 192.1.1 or .0.1 or something along those lines. That's because most of your home routers created today use this Class C range for configuring IPs on your network, because manufacturers are thinking in the back of their mind, if you have more than 255 computers, you're probably a business, not a home. And then you have additional IP ranges here. You have loopback addresses mentioned in RFC 300330 that range from 127.0.0.0 to 127.255.255.255. Again, that's 16 some odd million IPs used for loopback purposes. So a common use for this, if you're in IT, is that you maybe have your AD server or a DNS server set to a loopback address. So if you have a DNS server, you're probably not pointing to any other IP than the computer it's on, right? So it's kind of like a variable for saying the computer I'm on right now. So let's say if you want to access a web host, or let's say you want to access a web server on your computer just for testing a website, You don't need to type in the exact address of your computer. You just type in 127.0.0.1 and it always takes you to your computer, the computer you're actively on's web server at any point. And of course, there's aliases for that are called localhost that you've probably seen on any other computer out there. It's kind of be of a shorthand, so you don't have to remember the specific loopback address. But a loopback address can be any of these IPs that you see here, any of these 16 million IPs, but it's most commonly 127.0.0.1. Again, lots of wasted IP space, but that is what the formality is. And then you have what's called APIPA IPs, which are automatic private IP addressing that range from 169.254.0.0 to 169.254.255.255 that use a /16 CIDR notation. You may ask, this seems kind of really out of left field. What is this used for? Well, sometimes when your computer connects to a network, it may be possible that whatever upstream networking device, their DHCP server isn't working. Well, if that's the case, then what's going to happen is Windows will automatically assign an IP address to your computer. And I do want to kind of state this is a Microsoft technology. So if you're connecting to a network, but for some reason the network is not providing you an IP, and your computer is set for DHCP, not a static IP, then your computer will be randomly assigned a number within the range of 169.254.0.0 to 169.254.255.255. And if you've run an IP config on your computer to do some troubleshooting on why you can't connect to a certain network, well, that's probably why, because Microsoft was kind of thinking ahead to kind of make the user experience a little more friendlier, if you will. Thanks for watching today's video. Hope you enjoyed it. Want to see more videos on my channel? Click here.